Now we take up various methods of integration. First is integration by substitution. To explain this method, I am taking an example. Let I be equal to integral sine square theta cos cube theta d theta. We have this integral. How to make a substitution? Now let sine of theta be equal to t. Then what we do is differentiate both sides. Differentiation of sine theta with respect to theta is cos of theta, and differentiation of t with respect to theta is dt by d theta. And this can be written as cos theta d theta is equal to dt. Cos theta d theta is dt. So we write I equal to integral sine square theta into cos square theta. We separate one cos theta from this. This will be cos theta d theta. Now cos theta d theta is dt. This is dt. And we must express the rest of the question also in terms of the new variable. This will be dt. And rest of the question should be expressible in terms of the new variable. So we write this as sine square theta, because sine square theta will be t, and this can also be changed into 1 minus sine square theta. So this will be 1 minus t square, and this will be cos theta d theta. So this will be dt, this will be 1 minus t square, and this will be t square. So we have converted this question in terms of the new variable, and this is equal to integral t square into 1 minus t square into dt. Now how to integrate this? We will multiply these two terms and we will get t square minus t 4 dt, and this is equal to integral t square dt minus integral t4 dt, and this is equal to t cube by 3 minus t to the power of 5 by 5, t4 plus 1 over 4 plus 1, x to the power of n. Integration of x to the power of n is xn plus 1 over n plus 1. So this is equal to, and here we must take a constant of integration. Now t is the sine of theta, so this will be sine cube theta by 3 minus sine 5 theta by 5 plus c. So this is how we make a substitution. Put sine theta equal to t. So this will be cos theta is equal to dt by d theta. Therefore cos theta d theta is equal to dt. Now separate one cos theta from this. This is the simplification part, and we should be able to express the rest of question in terms of t. Then this substitution will work. This will change the question into two simpler questions which we have been able to solve. So purpose of substitution is to convert this into simpler forms whose integration is known. Now I make another substitution and explain you why this substitution is not working. It is very important. Which substitution is not working? This is working, but there can be substitutions which will not work. For example, in this question we can try cos theta equal to t. Put cos theta equal to t. Then differentiation of cos theta is minus sin theta d theta is equal to dt. Differentiation of cos is minus sin theta, which is dt by d theta, and we can directly write minus sin theta d theta is equal to dt, and therefore I is equal to integral we can write this as sine square theta. So cos cube theta, we separate one sine from this and get integral sine theta cos cube theta sine theta d theta. Now this is dt. This is t cube, but we are not able to convert this in terms of t. There is no formula for converting sine theta into cos theta. If we use sine square theta plus cos square theta equal to 1, then we will get under the root 1 minus cos square theta into cos cube theta into sine theta d theta, which is not making the question simple. It is further complicating the question. This will be under root 1 minus t square into cos cube is t cube into dt, which is very complicated, and therefore this substitution will not work. This is making the question more complicated. It is not simplifying the question like in this substitution. It is further complicating the question, and in the absence of chain rule for integration, we will not be able to integrate this easily. I once again explain you how to carry out this substitution. Now, when we put sine theta equal to t, we must keep 2 points in mind. One is simplification. This is the simplification part. Cos theta d theta is changing into d theta. And second is rest of the question should be easily expressed in terms of the new variable. This is changing into t square into 1 minus t square dt. This is the simplification part, and rest of the question is changing into a simple question in terms of the new variable. Here, if we make cos theta equal to t, this may be regarded as the simplification part, but rest of the question is not expressible in terms of the new variable easily. So this will not work. Now I take up some simple questions to explain you how to carry out these substitutions. One is simplification part, and rest of the question should be expressible in terms of the new variable. These 2 points you must keep in mind. Now first is integral x into sine x square plus 1. Now if I put x square plus 1 equal to z, then what we will get is differentiate this. We will get 2x dx will be dz. So x dx will be the simplification part. So this will be gone in simplification, and this is sine of z. So this question will be solved. Put x square plus 1 equal to t. Then differentiate this. What we will get is 2x will be dt by dx. But you should directly write 2x dx is equal to dt. You can leave this step. Differentiate both sides, we will get 2x is equal to dt by dx. So we can directly write 2x dx is dt. Therefore, I can be written as integral sine x square plus 1 into x dx. And from here we have x dx is equal to half dt. So this can be written as integral sine of t into half dt. This is equal to half integral sine t dt. And integration of sine is minus cos t. So this will be minus 1 by 2 cos of t plus c. And substitute this variable back. We will have minus half cos x square plus 1 plus c. So if I make this substitution, I must verify 2 points. First is This is the simplification part. So x dx will go in simplification. And rest of the question is easily expressible in terms of the new variable. This will be sin t. So this will be sin t dt. And you can easily solve it. Now, in this question, if I put say tangent x equal to z, then differential of tangent x is secant square x. Secant square x. So secant square x dx will go in simplification, and we will have secant square x into tangent x. And secant square x can be written as 1 minus tangent square x. So question will be easily convertible in terms of the new variable. If we put tangent x equal to t, then this will be secant square x is equal to dt by dx. Therefore, secant square x dx is equal to dt. And therefore, this I can be written as, we will separate secant square x from here and combine it with dx. So this will be equal to secant square x tangent x into secant square x dx. And this is equal to, we have separated this. This is equal to integral secant square. Secant square can be written in terms of tangent as 1 plus tangent square x into tangent x into, this is expressible as dt. This is dt and this has been expressed in terms of t. So this substitution will work. So this will be 1 plus t square into t into secant square x dx is dt. So this is equal to integral, open this bracket, t plus t cube dt. And this is equal to integration of t. Integration of t is t square by 2 plus integration of t cube. Integration of t cube is t4 by 4 and plus constant of integration. And this is equal to, now t square. T square is tangent square. Tangent square x whole divided by 2 plus tangent 4 x by 4 plus c. This is the answer. Now we try to make another substitution. I have written this as secant 4 is secant cube x into secant x into tangent x dx. And this is equal to integral, now secant cube is t cube and secant x tangent x is dt. So this is very simple. This will be t4 by 4 plus c, and this is equal to secant to the power of 4x over 4 plus c. This is a better method. This is more simple. Both substitutions are working, but this is making the question more simple. So instead of this, you must carry out this substitution. With practice, you will start finding out which substitution will be more simple. So this is the result. Now to give you practice on substitution, I am in the beginning dividing some questions into certain types. After some practice, we will forget these types. The substitution will start coming to your mind. So in the beginning, I am dividing the questions into certain types. Whenever a function involves an inner function, you must try inner function equal to t and see whether it is working or not. If it is working, carry out the substitution. Otherwise, think of some other substitution. So first is, if a function involves an inner function, try inner function equal to t. Now in this case, we have inner function as tan inverse x. So we must try putting tan inverse x equal to t. And before starting the question, you must carry out some steps mentally. Put tan inverse x equal to t. Then differentiate tan inverse x. It will be 1 over 1 plus x square. Differentiation of tan inverse is 1 over 1 plus x square. So 1 over 1 plus x square will go in simplification, and rest of the question will be expressible in terms of the new variable. So this substitution is working. So carry it out. Tan inverse x equal to t. Differentiate this. We will have 1 over 1 plus x square into dx is equal to dt. And therefore I is equal to integral sine, this is t, sine t, and 1 over 1 plus x square dx is dt. So we have reduced this into a very simple question, and integration of sine is minus cos t, and this can be written as minus cos, and t is tan inverse x. This is tan inverse x, and this is equal to, now we must change cos in terms of tan. A simple method is, we have tangent of x. If say this is theta, then tangent is this upon this. So let this be tangent of x and this be 1. So this will be under the root 1 plus tan square x, and therefore cos of theta will be equal to 1 upon under the root 1 plus tan square x. Therefore we can write this as minus 1 upon under the root 1 plus tan square of this, tan square of tan inverse x. So this whole square, and tan of tan inverse x is x. So we will have minus 1 upon under the root 1 plus x square. This will 1 over 1 plus x square. So this is the answer. You must change it in terms of x, and this can be used as a simple method to remember the formulae. Now next is this. Now here inner function is x ex. Try putting x ex equal to z. Put x ex is equal to t. X ex equal to p. So this will be x into differentiation of this ex. First function differentiation of second, plus second function into differentiation of first. This into dx is equal to dt. This can be written as ex is common, so we will have x plus 1 into ex dx is equal to dt. So this will go in simplification, and we will have 1 over cos square t, that is secant square t. So this is changing into a simple question. If we put x ex equal to t, this will go in simplification, and rest of the question is easily expressed in terms of the new variable. So this substitution will work, and we can write I as this. This is dt whole divided by cos square t, and this can be written as integral secant square t dt. Now integration of secant square t. Now secant square t is differentiation of tangent t. So integration of secant square t is tangent t plus constant of integration. So this must be equal to tan of t. T is x e x. This plus c. So this question is solved. Now in this question, inner function is root x. Put root x equal to t. Then differentiation of this is 1 by 2 root x dx is equal to dt. So this will go in simplification, and rest of the question is expressible in terms of t. So this substitution is workable. So I is equal to integral, this will be tan of t secant square t, and 1 by root x dx. 1 by root x dx is 2 dt. So this will be 2 dt. And this can be written as twice integral tangent t secant square t dt. But we do not still know the integration of this function. We make another substitution. Put tangent t equal to z. Because if we put tangent t equal to z, we will have secant square dt. So secant square dt will go in simplification, and this will be integration of z, and the question will be solved. So tangent of t, differentiate both sides. So we will have secant square t dt is equal to dz, and therefore I is equal to integral tangent of t. Tangent of t is z, and secant square dt is dz. So this is dz, and we have 2 outside. This will be twice z, and this will be dz. So this will be 2 into z square by 2 plus c. That is z square plus c, and z square is tangent of t. So this is tan square t plus c, and t is root x. So this can be written as tan square root x plus c. Now in this question we made 2 substitutions, and we express the result in terms of the original variable, that is x. So first we change z in terms of t, and then change t in terms of x. But instead of carrying these 2 substitutions separately, we could have made a single substitution. Put tan root x equal to t. With practice, you will start arriving at this substitution directly. So tan root x is equal to t. So differentiate both sides. We will have secant square root x. Differential of tangent is secant square x, and differential of inner function, this is 1 by 2 root x dx is equal to dt, and therefore we can write secant square root x into dx by root x is equal to 2 dt. Therefore I can be written as integral tan root x. Tan root x is t, and secant square root x over root x. Secant square root x over root x dx is 2 dt. So this is 2 dt. This is 2 dt. This is equal to twice into integral of t dt. Integration of t dt is t square by 2 plus constant of integration, and this is equal to t square plus c, and t is tan. So this is tan square root x plus c, which is same as this. But in general, these 2 answers can differ by a constant. This answer could have been tan square root x plus some constant, say 1, 2, 3. The two answers could have varied by a constant. Now these questions you can try yourself. In this inner function is cos x. In this inner function is cos square x. In here inner function is tan inverse x. Here inner function is log x. So substitute these and simplify these questions. Now we have this question. Here what we notice, if I substitute x square plus 9x plus 10 equal to t, then differentiation will be 2x plus 9. 2x plus 9 dx will go in simplification and we will have 1 by z. So put x square plus 9x plus 10 equal to t. So this will be 2x plus 9 into dx is equal to dt. So I can be written as integral dt, this will be dt, over this is t. So now this is log of t plus c. This is equal to log of x square plus 9x plus 10 plus c. The next topic we will be taking up is complete integrals. After discussing that topic, you can directly arrive at this result. It is shorter, but for practice of substitution, I am taking this question separately. Now in this question, we have this integral. And in this integral, what we notice, we have cos x dx. And cos is differentiation of sin x. So if I put sin x equal to z, then cos x dx will go in the simplification part. And rest of the question will be expressible in terms of the new variable, that is sin x. We put sin x equal to t. Its differentiation will be cos x dx. This will go in simplification and this will become 4t minus 5 or 7t plus 2. And the question will be solved. But instead of putting sin x equal to t, if we put 7 sin x plus 2 equal to t, 7 sin x plus 2 equal to t, then its differentiation will be 7 cos x and differentiation of this will be 0. 7 cos x dx equal to dt. So cos x dx will be dt by 7. 7 will come out and we will have in the denominator t to the power of 8, which will be very simple. So instead of putting sin x equal to t, if we put 7 sin x plus 2 equal to t, the question will be much more simplified, because differential of constant is 0. So we will take this along with the substitution. So what we do is we put 7 sin x plus 2 equal to t. Let us denote this integral by I. Then differential of this is 7, differential of sin is cos x. And differential of 2 is 0. So 7 cos x dx is equal to dt. Therefore, cos x dx is equal to 1 by 7 dt. Now we express this integral in terms of the new variable. From here we have a sine of x is equal to, this is t minus 2. Take this to the other side. T minus 2 and divide by 7. So sin x is t minus 2 by 7. So I will be equal to integral 4 into sin x. Sin x is t minus 2 by 7 minus 5 into cos x dx is 1 by 7 dt. And this is equal to t to the power of 8. and this can be simplified into, now 1 by 7 is common. 1 by 7 is common, and we take LCM of the numerator. So LCM of the numerator is 7. So 7 into 7 divided by 7, 1. So we will have 4t minus 8. I am opening this bracket. 4t minus 8. And this will be minus 35 dt. And this is equal to, now 1 by 7 will come out. So we will have 1 by 49 integral 4t minus 43. 35 minus 8. 43. This is this over t to the power of 8 dt. This is equal to 1 by 49 into integral. Now we will be able to solve this integral just by separating the terms. We will write this as 4t by t to the power of 8 minus 43 over t to the power of 8 dt. So this will be equal to 1 by 49 into, this is 4 integral 1 by t to the power of 7 dt minus 43 is common, integral of 1 by t to the power of 8 dt. And this is equal to 4 by 49 into, this will be t to the power of minus 7. So integration of this will be t to the power of minus 7 plus 1 over minus 7 plus 1. This will be the integral of this. And this will be minus 43 by 49 into integral of t to the power of minus 8. This will be t to the power of minus 8 plus 1 over minus 8 plus 1. And this is equal to 4 by 49 into, this will be t to the power of minus 6 over minus 6. Minus 43 by 49 into, this will be t to the power of minus 7 over minus 7. So this is equal to, now this cancels and we have 2 by 3. So 3 into 49 is 147. We will have 2 by 147 with negative sign into 1 by t to the power of 6. And this will be minus minus plus 43 over 49 into 7 is 343. And this is equal to minus 2 by 147 into, now t is equal to this much. So we will have 1 upon 7 sine x plus 2 to the power of 6 plus 43 by 343, and we have 1 by t to the power of 7 here. So we will have 1 upon 7 sine x plus 2 to the power of 7 plus constant of integration. So this is the answer. So if instead of 7 sine x plus 2 we put sine x equal to t, then we will have in the denominator 7t plus 2. So we will have 7t plus 2. So we will have to express the numerator in terms of 7t plus 2, which will be more complicated. Then only we will be able to separate this into two solvable integrals.